Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Ahmad Nauman, and today in this lecture we will discuss about the chemical properties of advanced materials. And specifically in this lecture we will discuss about the corrosion resistant properties of different advanced materials. In this lecture first we will discuss what is corrosion and how it is caused and what are the factors which result in the formation of corrosion, and then we will discuss how we can prevent corrosion and how the advanced materials are helping to prevent the corrosion of the metal surface. So let's first start with an animation about the corrosion, so that you have an idea that what is corrosion and how it happens and what can be the ways to prevent it. So let's watch the animation first and then we will continue.
Imagine four objects: an aluminium toy, an iron nail, a copper pipe and a gold ring are left out in the open for many years. Which of the four materials do you think will be in the best condition when they are rediscovered? Pause, think and continue when ready. If you think the gold ring is likely to be in the best condition, you're right. The copper pipe and the iron nail will appear in a worse condition, but the aluminium toy is also preserved very well. Most likely the iron nail will appear in the worst condition. This is because of corrosion. Corrosion is described as formation of compounds on the surface of a metal when it is exposed to air and or water or an electrolyte like salt water. Typically, once a metal corrodes, it forms compounds known as oxides or hydrated oxides. The nail, made of iron, rusted. This, by the way, is the only time you should use the term rusting. All other metals are considered as having been corroded when they react with water and or oxygen in the air. But why would the nail be more corroded than the aluminium toy, the copper pipe or the gold ring? Have you any ideas? Pause the video and continue when ready. The reason is the metals all have different reactivities. Iron corrodes faster because it is more reactive than the copper and the gold. But you may be wondering, well, why didn't the aluminium toy corrode the fastest? The truth is, the aluminium is more reactive than the iron, so it reacts fastest with the oxygen from the air, forming aluminium oxide. Aluminium oxide is very unreactive because once the oxide layer is formed on the surface, it binds very tightly to the surface of the metal, so no cracks can form and cause further corrosion. Here's a challenge. How might you use this idea to protect the iron nail? The answer is that by covering a metal like iron with another more reactive metal, like zinc, is that the zinc forms the zinc oxide layer quickly. The iron underneath is protected. This process is called galvanizing and can last up to 100 years. If you think of the metal on a bike, corrosion can be prevented by painting the frame, a static part, or greasing the metal parts like the chain which moves, or by covering it with a thin layer of a less reactive metal like tin, copper or gold, but that would be very expensive.
So that animation hopefully gives you an better idea about what is corrosion and how it is handled normally. So the word corrosion actually stands for metal or material deterioration or surface damage in an aggressive environment. Corrosion itself is an electrochemical oxidation process. We can call it is a redox process in which both oxidation and reduction occurs. In corrosion process normally होता है कि जो metal होता है हमारे पास ये normally transfers electrons to the environment, normally जो electrolyte है, water है और oxygen है, and it is oxidized as it gives electrons. and those electrons are actually accepted by the analyte, and mostly if it's oxygen in the environment, so it takes those electron and is reduced, and it makes oxides mostly with the metal. So these metal oxide, for example in the case of iron जो है they form actually the rust on the surface, और हम कहते हैं कि जो metal जो है वो corrode हो गया, there is corrosion happening over the surface. So basically it is an oxidation reduction process in which metal surface is oxidized by reaction with the environment, mostly water and oxygen. So in some cases ये भी होता है कि जो metal होते हैं they react with the oxygen which is present in the air, and they form metal oxide on their surface, and we call this process as a natural passivity or natural resistance to corrosion, as those layers are resistant to the corrosion. So the formation of that thin layer actually blocks the environment to react with the underlying the metal surface, and because it cannot undergo further reaction, so there is no more corrosion or no more reaction with the environment. So an example which we also see in the animation is that oxidation of aluminium mostly results in the formation of aluminum oxide, कि जो कि resistant होती है काफ़ी, and that it doesn't react. So that thin layer of aluminum oxide is actually formed on the surface of the metal, and it actually protects it from further contact and reaction with the oxygen. So due to the formation of that layer of aluminum oxide on the surface, जो नीचे वाली surface होती है that doesn't react and mostly जो है ये corrode नहीं होती, it remains safe from the corrosion. But in some cases ऐसा भी होता है कि जो protection film है जो है कई दफ़ा ये damage हो जाती है due to certain अगर उसके ऊपर कुछ stress पड़ा है या कोई बहुत ही harsh जो है वो environment है, in that case that actually film जो है that can be damaged or destroyed, and we call it that it is repassivated. The material जो है कि वो repassivate हो गया. So if we want to prevent corrosion, we have to understand कि ये कैसे होती है, because एक दफ़ा अगर एक मेटल जो है वो corrode हो जाता है, एक दफ़ा rusting हो जाती है, then जो है उसको ठीक करना जो है वो मुश्किल है. Once it is corroded, so then we have to replace it. So the only way is to आप corrosion होने ही ना दे, you have to prevent it earlier. So there is one important thing to know, that corrosion always happens in the presence of oxygen and water. So it requires both oxygen and humidity to happen. So if we हम इसको कोशिश करें कि इसका अगर जो हमारे पास मेटल सरफेस है, it is not exposed to oxygen and water, so in that way we can prevent the corrosion to happen. Another point is that it is the formation of rust or the corrosion is not the direct reaction of iron or a metal surface and its oxygen, but instead it is a electrochemical process. It is a redox process in which oxidation of metal occurs, and also there is a reduction of the oxygen which forms the metal oxides on the surface, but they are not directly reacting actually the oxygen and the metal.
Experiment. Place an iron nail in 4 test tubes. Fill one with regular tap water until the nail is submerged. Fill another with regular tap water and add half a spoonful of sodium chloride, regular table salt. Shake from side to side to ensure that sodium chloride fully dissolves. Fill the third test tube with recently boiled water and add a thin layer of oil. When we boil the water, we remove any dissolved oxygen, and the layer of oil prevents any oxygen from further dissolving. In the last test tube, add a spoonful of calcium chloride. Calcium chloride removes moisture or water. So in the first test tube, the nail is exposed to oxygen and moisture. In the second test tube, the nail is exposed to oxygen, moisture, and salt. So in the third test tube, the nail is only exposed to water. In the fourth test tube, the nail is exposed only to oxygen. Stopper all 4 test tubes with a rubber bung and let stand for a couple of days. You will find that the nails in the first and second test tubes have rusted. In particular, the nail in the second test tube has rusted more than the nail in the first test tube, and the rust has likely flaked off. You may see a reddish-brown precipitate at the bottom of these tubes. The nails in the third and fourth test tubes have not rusted. So what has happened here? The iron has undergone an oxidation reaction, forming hydrated iron-3 oxide or rust. Salt and acid act as a catalyst for this reaction, which is why the nail in the second test tube formed more rust than the nail in the first test tube.
So from the animation we have learned that it requires water and air for the corrosion to happen, and also we learned that अगर वहाँ पे salt present है, the presence of salt actually act as a catalyst and it enhances the corrosion process. So that actually explain कि जो ऐसे areas जो hilly areas होते हैं जहाँ पे mostly बर्फ़ पड़ती है और उसको बर्फ़ को पिघलाने के लिए रोड पे जो है mostly salt यूज़ किए जाते हैं different. सो दैट वो जो एरियाज़ होते हैं मोस्टली वहाँ पे जो ऑटोमोबाइल्स होती हैं वहाँ पे रस्टिंग ज़्यादा होती है, एंड दैट एक्चुअली एक्सप्लेन कि वहाँ पे रस्टिंग क्यों ज़्यादा होती है, बिकॉज दैट सॉल्ट एक्चुअली जो है वो डिज़ोल्व हो जाता है वाटर के अंदर, एंड विच एक्चुअली enhance the process of corrosion over there. And another thing which we learned in the animation was the redox process, which is occurring during the corrosion. So let's watch another animation which is describing in detail how that redox process is occurring, the oxidation of metal and the reduction of the oxygen is happening. So let's watch another animation.
The rusting of iron is an oxidation-reduction reaction. Here we can see the iron being exposed to a water droplet containing dissolved oxygen. This exposure causes each iron atom underneath the water droplet to give up 2 electrons to become iron 2 ions. This process is known as oxidation. Next, electrons are released and flow throughout the droplet, where the oxygen dissolved in water receives electrons to form a hydroxide ion. This is the reduction process. Next, iron 2 ions combine with hydroxide ions to form iron 2 hydroxide. Finally, iron 2 hydroxide reacts with water and oxygen to form iron 3 hydroxide, which is also known as rust.
So how we can protect the metal surface and prevent the corrosion? So it can be carried out in many ways, and there are different methods to prevent or control the corrosion process. So main requirement for preventing corrosion is that we protect the surface of a metal or iron or whatever the metal is, so that it cannot interact with the oxygen and the moisture from the atmosphere. So we have to shield the surface of the metal. So the main requirement जो है to prevent the metal from corrosion is कि हमने जो metal की surface है उसको protect करना है इस तरह से कि उसकी जो surface है वो पानी और ऑक्सीजन इनके साथ जो है वो interact ना कर सके. So we have to shield the surface from these two so that there is no corrosion process. And one method is कि हम जो है वो metal surface को है वो जो है paint कर दें. So it is also effective against the corrosion, but happens is कि if there is some really harsh weather, ऐसा जो है धूप है, बहुत तेज़ गर्मी है और जिसमें UV light बहुत ज़्यादा है, so that can actually damage the mostly paint surface. And also if there are excessive rains or there are some kind of scratch, so what happens is कि जो paint है वो जो है वो उखड़ जाता है. And also there is if there is extraordinary cold and especially in those area where there is snow, so in winter वो जो है chips जो है बन के उतरना शुरू हो जाती हैं कि जो paint की जो surface है वो damage हो जाती है. So the thing is कि paint is effective against the corrosion, but in cases if there is some scratch on the surface और अगर environment की वजह से surface of paint is damaged तो दोबारा corrosion जो है वो start हो जाती है. So in that case we have to repaint the surface. Another method is which is used कि sometimes electric current is used to produce some of the passive films or produce the some metal oxide films on the surface. So for that purpose it is provided with current which results in the formation of oxide layers on the surface which prevent the metal to react with the environment. So that is also helpful in prevention of corrosion. And in some cases कुछ metal surface होती हैं, they are treated with the laser actually, so they make them non-crystalline on the surface, and there are some materials if they are in the non-crystalline form, so they are resistant to corrosion. So that can also be a method to prevent corrosion. And in another method is कि हम जो है वो electroplating कर दें किसी metal के साथ के जो inert है. For example, we can electroplate a surface with gold or platinum which are very inert. So ऐसा होता है कि जो भी हमारे पास inert हैं, जो metals हैं जो react नहीं करते हैं, जिनको corrosion नहीं होती, for example gold है या जैसे platinum है, so उनकी जो है electroplating की जाती है, coating कर दी जाती है metal की surface पे, so that they are resistant to corrosion. Similarly there are some other metals जैसे magnesium है, chromium है, titanium है and zinc है, so they also form the protective oxide coating. So we can also coat the material with these metal oxide and it will help in the prevention of the corrosion. But in case of iron depend करता है कि जब हम metal oxide जो है अगर उसकी coating करना चाह रहे हैं किसी भी metal की surface पे, उसको avoid करें ताकि वो corrosion ना हो सके. So that actually depends what kind of metal we are using. There are some metals whose oxides are inert, but there are some metals whose oxides actually can react. So there is no use of coating with those oxides. For example, in case of iron, so iron oxide है, it is actually it becomes porous. So even if there is oxide layer on the surface of the iron metal, but still there will be oxidation because it cannot prevent the underlying surface of the iron to contact with the environment. The steel जो है mostly जो use की जाती है automobiles में, तो उसको जो है वो corrosion से कि वो prevent करने के लिए what happens कि उसको जो है वो zinc के अंदर dip किया जाता है, molten zinc use की जाती है और उसके ऊपर coating कर दी जाती है zinc की on the surface of the स्टील, ताकि जो है उसकी corrosion हो जाए, जिसको प्रोसेस को galvanizing भी कहा जाता है. इसके अलावा not only zinc, there are other non-metallic coating as well. For example, different kind of plastics हैं, paints हैं, oils हैं जिनकी जो है वो coating की जा सकती है to prevent the corrosion of the metal surface.
If we paint the areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another method to prevent rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps lubricate the moving parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a sacrificial protection method called galvanizing. Have a look at this reactivity table. Zinc is more reactive than iron. When exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put them together, zinc protects iron but is sacrificing itself, hence the term sacrificial protection. This method is applied to prevent rusting on ships. The oxidation of zinc can be described using this following equation. So besides preventing rusting, there is another advantage to this galvanizing process. The formed zinc oxide layer can be removed, and the freshly exposed zinc can corrode once again, thereby further protecting the iron or steel hull.
So now we will discuss how the nanotechnology or the advanced materials can be used for the inhibition of corrosion or corrosion prevention. So we know that nanostructure materials in the past 1 or 2 decades, they have actually established themselves as a very high performance materials in different areas of engineering, medical and material research, and also in chemistry and physics. And that is mainly because of their very unique properties. When we talk about nanomaterials, we know that their size is really small, and because of that reduction in size, so they have some extraordinary properties. For example, they have very high surface energy. With reduction in size, their surface area increases significantly, and with reduction in size, the different physiomechanical and physiochemical properties of the materials are enhanced, and they are really different and better than the bulk material or the micro materials. So because of those really when we talk about nanomaterials, they are used in so many applications. They are really effective. Their efficiency is very good. So there is an idea that we can use this technology for inhibition of corrosion. So then there is talk about the development of some really high performance coatings which have nanomaterials in it, so that can be used to protect the metal surface from the corrosion. So nanostructure mostly material होते हैं कि इनकी जो properties होती हैं when we compare them with the bulk material. For example, हमारे पास कोई भी metals है, for example copper है, so एक bulk material है, और अगर हम उसके nano particles की बात करें तो उनकी जो properties होती हैं they are really different, because when we increase the size of a material to nano level or sub micro level, so इनका जो surface area होता है वो बहुत ज़्यादा increase हो जाता है. जब अब when you talk about increase in surface area, it means कि जो उनकी active centers हैं या जो उनकी reactive sites हैं वो भी ज़्यादा हो जाती हैं with decrease in the size. So that's why the nanostructure materials have very improved properties when we compare them with their bulk materials. So when we talk about use of the nanomaterials for corrosion inhibition, so there nanomaterials, if we use them in coating, so nanomaterials can actually there are two methods by which they can absorb or they can cover the surface of the metal. First is they can physically absorb on the surface, or they can interact chemically and have a chemical absorption on the surface of the metal, and they can cover the surface and can inhibit the corrosion significantly. So the use of nanomaterials in general used coating for the metal surface, which is used for prevent corrosion, actually these nanomaterials, that they can enhance the corrosion protection because they have a very small particle size and their surface area is really high. So they can improve the properties of the coatings in which they are used. So the coating have the high lifetime and higher efficiency against the corrosion inhibition. And nanomaterials are mostly preferred in the general their introduction into the coating materials because they can enhance the efficiency, also because their surface area is very high, so the amount of nanomaterial used will be low as compared to if we are using the bulk material. So that will definitely also save the cost, and there will be easy production of the material, and it will be more effective against the corrosion inhibition. Because of these properties, ये भी कहा जाता है कि nanotechnology के there are so many uses, there are different commercial uses, लेकिन जो coatings हैं nano enhanced, they have so versatile application. And जो main benefit है जब हम nano coating की बात करते हैं, so they actually give durability to the coating on the surface. Also when we are using nano coating, so just the strength होती है coating की, that is also enhanced. Similarly, in some cases we require some optical quality, so we can use those nanomaterials which enhance the optical properties of the coating. So जो optical जो properties होती हैं वो भी better होती हैं if we are using nano coating. And the more important thing, because we are, for example, in Pakistan we have hot summers, so if we are using nano coating, so they have the high thermal stability. So जो वो coatings होती हैं वो high temperature पे भी efficient रहती हैं और वो damage नहीं होती. So there are these many advantages of nano coating if we compare them with the conventional coating. So that's why जो nano coating जो है, this is the most widely accepted approach for the corrosion control. So it is the most preferred approach जो है वो corrosion inhibition की, कि उसके ऊपर जो है वो nano coating की जाए surface के ऊपर on the metal surface. So that is the most commonly used method nowadays against the corrosion inhibition. So जब हम बात करते हैं thin film coating की या materials की, तो there are different kind of materials जो कि use हो रहे हैं. Depend करता है कि आपके पास कौन सी metal surface है और आप कहाँ पे उसको apply कर रहे हैं, where you are going to use that actually metal or the material. So depending on their application or the end use जो है वो decide किया जाता है कि what kind of coating should be done. So there are so many materials which are used for the film coating. For example, there is polyurethane है, there is polyamide, polyesters, PVC, acrylics, alkyds and epoxy coatings. So there is a variety of materials which can be used for the purpose of thin film coating to protect the metals from the corrosion. So how the question is कि जो coating है ये कैसे prevent करेंगी against the corrosion. So the main role of this coating is कि ये delay करती हैं corrosion को. How कि they prevent the reactive species. For example, chlorine है, hydroxyl ion है, water है, oxygen है, there can be many other pollutants कि जो कि oxidative in nature होते हैं, which can जो कि oxidize कर सकते हैं metal surface को, and they have high affinity to react with the metals. So these coating actually act as a barrier कि जो metal को protect करती हैं from these different pollutants or pigments के जो कि metal को oxidize कर सकते हैं. So another important thing is कि ये जो हम we can use the coating. For example, normally paint use करते थे, हमने discuss किया कि जब paint use करते हैं तो its surface can be damaged by some harsh environment. सो सिमिलर जो हम नैनो कोटिंग यूज़ कर रहे हैं सरफेस के ऊपर, सो दे कैन आल्सो गेट डैमेज, दैट कैन बी बाय फिजिकल मेथड्स और केमिकल मेथड्स. So there are different ways different things which can damage the surface of the thin film coating. For example, they can get swell by water absorption, or they can be dissolution. For example, we are using some zinc oxide and we know that जो zinc oxide होती है, for example अगर एसिडिक आपके पास वाटर है और जो zinc oxide है वो उसके अंदर बहुत easily dissolve हो जाती है. So if we are using zinc oxide coating and it is exposed to some acidic condition, so वो जो उसकी जो layer है वो उसकी dissolve हो जाएगी, डैमेज हो जाएगी. Similarly, if there is a high strength UV light है, so that can actually change its color or it can damage its surface. Similarly, if we are talking about very हाई टेम्परेचर का, अगर इसको किसी मटीरियल को किसी ऐसी जगह यूज़ किया जहाँ पे टेम्परेचर बहुत ज़्यादा है, सो दैट हीट कैन आल्सो एक्चुअली डैमेज द सरफेस. सिमिलरली, इफ वी आर यूजिंग इट इन द आउटडोर सम कोटिंग्स एंड there is some acid rain in those areas, so that acid rain also can damage the surface. So there can be different things or factors which can damage the surface of the thin film. For example, this diagram below shows that there can be oxygen which can oxidize the thin film surface. UV light can also जो है वो डैमेज कर सकती है थिन फिल्म को. सिमिलरली जो मॉइस्चर है, जो वाटर है, इट कैन हैव नेगेटिव और डिटेरियोरेटिंग effect on the thin film. And the second diagram you can see that this is the film के जिसके ऊपर काफ़ी सारे स्क्रैच भी हैं, and this film is really damaged. So after this, like if it's in this condition, whether it is by physical ways or by chemical method, अगर damage हो गई है, so it cannot prevent further the against the corrosion. So we have to paint it again, or we have to coat it again. So which is actually tedious process, as well as it adds to the cost. So what is the solution for this? That we should enhance the strength of these and efficiency of these thin films, so which can be used by incorporating some different functionalized nanomaterials to depend करता है कि अगर आपने किसी ऐसी एप्लीकेशन है जहाँ पे फॉर एग्जांपल टेम्परेचर ज़्यादा है, सो आप इन कोटिंग्स के अंदर वो नैनो मटेरियल डाल सकते हैं, उनकी सरफेस फंक्शनलाइजेशन ऐसी कर सकते हैं कि जो ज़्यादा हीट पे जो है वो बर्दाश्त कर सकते हैं. सिमिलरली इफ़ इट इज़ यू हैव टू यूज़ इट आउटडोर्स और जहाँ पे सनलाइट बहुत स्ट्रॉन्ग है, सो वी कैन ऐड दोज नैनो मटीरियल which protect it against the UV light radiation. So by incorporating these nanomaterials, we can prolong the life of these thin films, and we can actually enhance also their efficiency. So by this way we can increase their efficiency, and also we can reduce the cost which for their replacement, or which is अगर आप दोबारा उसको कोटिंग करने पड़ता है बार बार, तो जो कॉस्ट होती है आप उसको भी बचा सकते हैं. So as we discussed in the previous slide कि we can use nanomaterials and हम उनकी chemical functionalization कर सकते हैं. अगर हमारे पास एक नैनो मटीरियल है और उसको हमने किसी ऐसी जगह यूज़ करना है जहाँ पे वाटर बहुत ज़्यादा है, तो हम उसके अंदर ऐसे फंक्शनल ग्रुप उसकी सरफेस पे लगा सकते हैं विच आर हाइड्रोफोबिक, कि जो वाटर को जो है वो रिपेल करते हैं. सो वी कैन प्रोटेक्ट इन दिस वे दैट सरफेस अगेंस्ट द वाटर. सिमिलरली वी कैन ऐड दोज मटीरियल जो कि यूवी लाइट को जो है वो अगेंस्ट जो है वो उनकी स्ट्रेंथ ज़्यादा होती है, सो हम वो मटीरियल ऐड कर सकते हैं. इसी तरह अगर हमें जो है वो ऐसी एप्लीकेशन है जहाँ पे जो कोटिंग है उसको ऐसे इन्वायरमेंट के एक्सपोज होना है जहाँ पे टेम्परेचर बहुत ज़्यादा होना है, तो हम नैनो मटीरियल की जो सरफेस है उसको ऐसे जो है तरीके से उसको फंक्शनलाइज करेंगे, उसके ऊपर ऐसे इस तरह की मटीरियल लगाएंगे कि जो हाई टेम्परेचर पे रेजिस्टेंट और जो उसकी स्टेबिलिटी को और थर्मल स्टेबिलिटी को इन्हांस करते हैं. So there are different actually kind of material which are used for. Normally the nanomaterial mostly use होते हैं depending कि कहाँ पे अप्लाई कर रहे हैं और कोटिंग किस तरह की है. सो वी कैन add different kind of nano materials. For example, we can use SiO2, we can use titanium dioxide, we can use zinc oxide, we can use aluminum oxide, and there are so many nano materials which can be used in the thin film coatings to enhance their efficiency against corrosion. So there is another possibility of changing the composition of the thin layer coating के आप डिपेंड करता है कि आपने जो भी कोटिंग है कहाँ पे यूज़ करनी है और जो मटेरियल है आपने उसको कहाँ पे यूज़ करना है. सो डिपेंडिंग ऑन दैट वी कैन यूज़ डिफरेंट काइंड ऑफ कोटिंग. So one of the option is that we use the hybrid coatings which serve multiple functions on the surface of the metal to prevent it against the corrosion. So one method is that we use the hybrid coating of inorganic components and organic components. So inorganic components which are mostly the nano particles. So जो nano particles होते हैं they enhance actually their resistance और scratch resistant जो है resistance है उसको increase करते हैं और also उनकी जो adhesion होती है thin layer की with the metal surface उसको enhance करते हैं. And depending कि आपने कौन सी कोटिंग यूज़ कर रहे हैं, आपने कहाँ पे मटेरियल को यूज़ करना है, तो आप कोई डिफरेंट नैनो मटेरियल यूज़ कर सकते हैं. एंड द सेकंड हम जो है जो हाइब्रिड कोटिंग है उनके ऊपर हम ऑर्गेनिक कंपोनेंट यूज़ करते हैं और ऑर्गेनिक कंपोनेंट का जो है वो डिफरेंट फंक्शन होता है. फॉर एग्जांपल जो है इन्हेंसेस द डेंसिटी ऑफ द कोटिंग और जो उसकी फ्लेक्सिबिलिटी होती है कोटिंग उसको जो है वो इंक्रीज़ करता है. सो बाय यूजिंग दिस हाइब्रिड कोटिंग वी कैन आल्सो enhance the efficiency of these thin layers on with when we talk about the against the corrosion inhibition. So by using these hybrid coatings we can get coating of our desired composition to ensure कि जो हमारी corrosion inhibition है वो maximum है in that given environment. But as we discussed in the previous slide, it totally depends कि what is your application, कि आपने उस मटेरियल को कहाँ पे यूज़ करना है. So depending if there is we are using a material outside और जहाँ पे बहुत ज़्यादा UV से expose हो रहे हैं, so we can use those materials वो nano particles के जो act as a UV blocker. So in those coatings we can, as for example nano zinc oxide है या cerium oxide है. So these have very excellent photo and thermal stability. So अगर हम इनको यूज़ करते हैं तो what happens is कि they enhance the stability of the coating against the UV light. Similarly, we can use some composite of zinc oxide and epoxy, and we can use them as the coating on the metal surface. So they also very effective against the सिनेरियो कि जहाँ पे यूवी लाइट बहुत ज़्यादा होती है. सो दे आल्सो प्रोटेक्ट द कोटिंग. सो जो है वो ताकि जो कोटिंग है वो उसको एक्सपोज ना हो, उसकी जो सरफेस है मेटल की वो एक्सपोज ना होने दो और वो जो है वो corrosion को प्रिवेंट करती है. सिमिलरली अगर आपके पास जो है वो किसी ऐसी जगह आपने कोई एप्लीकेशन है कि जहाँ पे बहुत ज़्यादा स्क्रैच होता है या एब्रेशन है, तो in those coating we can add nano silicone oxide or nano aluminum oxide or zirconium oxide. So by using these nanomaterials we can improve the mechanical properties and for example their hardness and scratch resistance of those thin films. So by using these nanomaterials जो हम उनकी strength है जो against scratch and abrasion उसको enhance कर सकते हैं. So they last long and they can prevent against the corrosion for longer time periods. So far we have discussed के जो coating जो है हम use करते हैं different और जो galvanizing use करते हैं ताकि उसकी surface जो है उसको हम protect कर सकें corrosion से. But there are certain cases कि जहाँ पे सिर्फ हमें उसकी surface को coat करने से जो है फ़ायदा नहीं होता. For example जब हम बात करते हैं aircrafts की, तो वहाँ पे जो steel use हो रही है वहाँ पे ना सिर्फ आपको corrosion protection चाहिए बल्कि आपको very high strength भी चाहिए. So in such a case जो है what we do is कि जो स्टील है उसको मॉडिफाई किया जाता है, उसकी स्ट्रेंथ को इंक्रीज़ किया जाता है और उसके अंदर इस तरह से चेंजेस की जाती हैं कि वो इटसेल्फ जो है वो corrosion रेजिस्टेंट होती है. वी नो के जो स्टेनलेस स्टील्स जो होती हैं कोरोजन रेजिस्टेंट होती हैं और देर आर डिफरेंट काइंड ऑफ स्टील्स अवेलेबल. सो नॉर्मली जो है अगर आप इसको बात करें स्टेनलेस स्टील की जो हाई एफिशिएंसी जो मटेरियल्स के लिए यूज़ होती हैं तो नॉर्मली इसको 5 डिफरेंट कैटेगरीज में कैटेगराइज किया जाता है और दैट एक्चुअली डिपेंड्स कि उसके अंदर क्या क्या मौजूद है, क्या कंसनट्रेशन है डिफरेंट जो कंपाउंड्स हैं. सो नॉर्मली जो स्टेनलेस स्टील यूज़ हो रही हैं दे कंटेन सम कार्बन होता है उनके अंदर. इट्स अमाउंट मे वेरी फ्रॉम 0.08 to 0.025%, and it contains chromium that can be from 12 to 26%, and also it contains nickel जो है up to 22%. So depending कि इनकी रेशो कितनी है, इनकी अमाउंट कितनी है, the steels are given different names. And the purpose of adding these actually nickel, chromium and carbon is to increase the mechanical strength of the steel and also the corrosion resistant. So for case of aircraft जहाँ पे बहुत ज़्यादा जो है वो स्ट्रेंथ भी चाहिए एंड आल्सो corrosion resistant, so there is a specific kind of steel जो वहाँ पे यूज़ होती है जिसको precipitation hardening steel कहा जाता है, जिसको PH stainless steel कहा जाता है. एक स्पेसिफिक काइंड ऑफ स्टील होती है जिसको हार्डन किया जाता है थ्रू बाय ट्रीटमेंट एट हाई टेम्परेचर. और ये जो स्टील होती है आफ्टर हार्डनिंग जो है इट कैन विथस्टैंड वेरी हाई प्रेशर and high temperature, and also it is corrosion resistant. And it is for example अगर वहाँ पे बारिश होती है क्योंकि because aircraft have to wear all kind of environment with high pressure, high or very low temperature and also the moisture. So these kind of steels are used there which are resistant to all of them and they are of very high strength. So that प्रीवियस स्लाइड हमने डिस्कस किया अबाउट जो एयरक्राफ्ट होते हैं उनके लिए स्टील. नेक्स्ट हमारे पास जो होता है जो पानी के अंदर शिप चलते हैं तो दे हैव अ टोटली डिफरेंट इन्वायरमेंट, सो दे हैव टोटली डिफरेंट रिक्वायरमेंट. सो वी हैव टू प्रिपेयर और वी हैव टू यूज़ अ टोटली डिफरेंट kind of steel which have totally different properties. So in for that ships actually to avoid the corrosion resistant and to give the high mechanical strength of steel, because जो ship होते हैं वो sea के अंदर चल रहे हैं और वहाँ पे जो है sea water जो है वो that mostly contains around 4 to 5% जो है वो, and depending on actually कौन से ocean है वहाँ पे उसकी different concentration होती है सोडियम क्लोराइड की. सो जो सोडियम क्लोराइड होते हैं या जो सॉल्ट्स होते हैं हमने पहले भी पढ़ा था कि वो इन्हेंस करते हैं, कैटलाइज करते हैं क्रोजन रेजिस्टेंस को, क्रोजन को. सो इन दैट केस वी हैव टू यूज़ अ स्पेसिफिक काइंड ऑफ मटेरियल विच इज़ हाईली रेजिस्टेंट टू क्रोजन एंड विच हैज़ आल्सो वेरी हाई स्ट्रेंथ. सो फॉर दैट पर्पज जो द स्टील यूज़ होती है जो उन शिप्स के अंदर उसके अंदर जो है वो सीरियम को ऐड किया जाता है ड्यूरिंग द कोर्स ऑफ मैन्युफैक्चरिंग. And it is observed कि by the addition of cerium to the stainless steel उसकी जो corrosion resistant होती है नॉर्मल जो stainless steel होती है उसकी निस्बत बहुत ज़्यादा हो जाती है. और another advantage of cerium है ये भी होता है कि ना सिर्फ उसकी corrosion resistance increase हो रही है बल्कि cerium को ऐड करने से उसकी जो strength है, जो mechanical strength है और tensile strength है, it is also enhanced around 10%. So डिपेंड करता है कि आपने जो है वो आपकी जो यूज़ कहाँ पे है. सो डिपेंडिंग ऑन दोज कंडीशन देर आर डिफरेंट जो है वो तरह की जो मॉडिफिकेशन की जाती है मटेरियल्स के अंदर टू अवॉइड द corrosion. एंड देर इज़ अनदर वेरी इंपॉर्टेंट फील्ड कि जहाँ पे हमें corrosion resistant मटेरियल चाहिए होते हैं और वो है एनर्जी रिलेटेड के जहाँ पे वेस्ट से एनर्जी प्रोड्यूस की जाती है. एंड नॉर्मली दीज एनवायरमेंट्स have very high temperature, so we need such material which are corrosion resistant at very high temperature, because these processes involve steam, and that steam it has temperature above 400 degrees Celsius, and also जो pressure जो होता है वो it's more than 3.9 megapascal. So in these boilers अगर there is a little bit corrosion, so जो है corrosion अगर वहाँ पे हो जाती है so that can result in the blast of the boilers, because उसकी जो कहीं से भी थोड़ा सा वीक होता है तो ब्लास्ट हो सकता है. सो इन सच जो बॉयलर्स होते हैं वहाँ पे ऐसे मटेरियल यूज़ करने पड़ते हैं कि जो बहुत ज़्यादा corrosion रेजिस्टेंट हो और जिनकी जो मैकेनिकल स्ट्रेंथ हो बहुत ज़्यादा हो, जो वेरी हाई टेम्परेचर और प्रेशर को विथस्टैंड कर सकें. सो देर आर डिफरेंट kinds of corrosion resistant materials and coatings which have been developed for use in that kind of application where high temperature is used. For example, aluminium spray किया जाता है, एक special kind of alloy है which is known as 80 Nickel 20 chromium alloy, and that is also used for high temperature environments. Then we have HVOF sprayed nickel chromium silicon boron alloy है. Actually HVOF stands for high velocity oxygen fuel. This is another kind of spraying technique, and there is another kind of alloy. So there are multiple kind of alloy. For example, there is another kind of steel which is 310S type of stainless steel कहा जाता है, that is used for boilers and high temperature environment. And there are some other alloys, for example chromium, molybdenum, nickel alloy. And there are also some kind of high durability coatings which are used on the metal surface to avoid the corrosion in high temperature environment. इनको cermet कहा जाता है. Cermet is basically a core term which is used for metal and ceramic. So Cer is for ceramic and MET is for metal. So these are actually composite materials made from ceramics and metals, and which have a very high resistance to corrosion. So their coating is actually used on the metal surfaces and for their use in very high temperature environment. So what does it mean is that depending where we have to use that metal and to avoid the to protect it from the corrosion, we use different kinds of alloys, we can use different kinds of coatings, we can use different functionalized nanomaterials embedded into those coatings to protect the surface from the environment. So in this table I have tried to summarize some different materials which are used in different applications. For example, if we are dealing with peroxides, amines or organic acids, so the preferred material is aluminium, which helps in the protection from corrosion. For the industries which are using hydrocarbons, some petroleum fractions or oxides or glycols, so there we use steels. Sometimes we use alloy steels, and in some cases, for example, where we are dealing with acids, for example nitric acids and phosphoric acid, urea, organic acid, so we are using stainless steels. In case we are dealing with aldehydes, alcohols and some specific organic acids, so we protect the metal surface from corrosion by using some copper alloys. While if we are using some very high concentrated nitric acid, or we are using sulfuric acid, caustic soda, chlorine, so we use nickel alloys. Similarly, for different kind of compound, for example fuming nitric acid, sulfuric acid or chlorine, we can also use some titanium, tantalum or zirconium material on the surface of the metal to protect it from the corrosion. So that shows कि हमारे पास डिपेंडिंग कि हम कौन सी इंडस्ट्री है, कौन सी एप्लीकेशन है, वहाँ पे हम कौन से केमिकल स्पीशीज़ जो हैं वो मौजूद हैं which can cause corrosion. So depending on the specific environment we decide what kind of material is required there to protect it from corrosion. Thank you. That's all for today. I really hope कि आपको इसमें से कुछ ना कुछ ज़रूर समझ आया होगा. And in case you have trouble in understanding some terminologies, और अगर किसी चीज़ की समझ नहीं आए आपको, so you are really free to ask any questions. So please listen this lecture carefully and let me know if you don't understand anything. Thank you. Allah Hafiz.